Your Android phone has 3 default settings that are actively working against you right now. Not theoretically, not in some edge case scenario involving sophisticated hackers and targeted attacks. Right now, as you read this, these settings are operating in the background of your device, sharing your location with companies you have never interacted with, opening doors for malicious apps to read your banking information, and creating vulnerabilities in the accounts that hold your most sensitive personal data. The settings were not designed to harm you. They were designed for convenience, for functionality, for features that someone in a product meeting decided would make your experience smoother. But the way they work in practice, in the actual environment your phone operates in, makes them attack surfaces that expose personal data to third parties, ranging from retail corporations tracking your shopping behavior to criminals looking for pathways into your financial accounts. The good news is that fixing them takes less than 10 minutes. No technical expertise required, no tools, no cost, no trade-off that significantly affects your daily use of the phone. The bad news is that most Android users have never heard of any of these settings because the people who benefit from keeping them on have no incentive to tell you they exist. Let us change that. The problem with default settings. Before we get into the specific settings, it is worth understanding why Android ships with default configurations that expose users to these risks rather than starting from a more protective baseline. Android is a platform that supports a complex commercial ecosystem. Google's business model depends on data. The applications distributed through the Play Store generate revenue through advertising, and advertising targeting depends on data. The retail and commercial infrastructure that intersects with Android devices generates value from user behavior data. Default settings that maximize data availability serve these commercial interests. Default settings that maximize user privacy would reduce data flows that the commercial ecosystem depends on. This is not a conspiracy. It is the logical outcome of building a platform whose revenue model is data dependent. The defaults reflect whose interests the platform primarily serves. Understanding this does not require distrust of every Android feature or every Google service. It requires recognizing that the default configuration of your device is not necessarily the configuration that best serves your interests, and that adjusting it toward your interests is your right and your responsibility. The 3 settings we are about to discuss are specifically chosen because they combine high risk with low awareness. Most users have never thought about them. Most users are actively harmed by them being on, and turning them off has minimal impact on the functionality users actually value. Setting 1, Wi-Fi and Bluetooth scanning. Go to your Settings app right now, tap Location. Look for a subsection called Location Services, or depending on your device manufacturer, it might be under Advanced or More Options. Inside that subsection, you will find 2 toggles, Wi-Fi scanning and Bluetooth scanning. On most Android devices, both of these are enabled by default. Read what they do carefully, because the description is easy to misread. These settings do not control whether your phone connects to Wi-Fi networks or Bluetooth devices. They control whether apps and system services can scan for Wi-Fi networks and Bluetooth devices, even when your Wi-Fi and Bluetooth are turned off. When Wi-Fi scanning is enabled, apps can ask your phone to scan for nearby Wi-Fi networks to determine your location, even when you have deliberately turned off Wi-Fi. When Bluetooth scanning is enabled, apps can scan for nearby Bluetooth devices to determine your location, even when you have deliberately turned off Bluetooth. The location inference from these scans is precise. The pattern of Wi-Fi networks detectable at a given location is as unique as a fingerprint. A device that detects a specific combination of Wi-Fi network names at a given moment is in a specific location, and the system that correlates those network patterns to physical locations has been building its database for years with data contributed by every Android device that ever ran a location-aware service. Here is the practical consequence that retail companies have built entire analytics businesses around. When you walk through a shopping mall with Wi-Fi scanning enabled, your Android phone is scanning for nearby networks continuously, even if Wi-Fi is off. Each scan produces a fingerprint of detectable networks at your current position. That fingerprint maps to a location within the mall. As you move, the fingerprints change, and the sequence of changing fingerprints is a map of your movement through the space. This data is collected by apps running on your phone, transmitted to their servers, and sold to analytics companies that supply it to retailers. The retailer learns how long you spent in each section of their store, which products you stood near, whether you visited a competitor before or after visiting their location, and how your in-store movement patterns correlate with your purchase behavior. You did not consent to this individually and specifically. You consented to it in the aggregate when you agreed to the terms of service of whichever apps are using this capability, terms of service that virtually nobody reads in their entirety. The Bluetooth scanning component is how the beacon tracking system we have discussed in other contexts gets its data. Even with Bluetooth off, Bluetooth scanning allows apps to detect the signals broadcast by Bluetooth beacons installed in commercial spaces. Turn both of these off. Go to Settings, Location, location services, and disable Wi-Fi scanning and Bluetooth scanning. Your actual Wi-Fi and Bluetooth connectivity are not affected. Your phone will still connect to networks and devices you have saved or that you manually connect to. What changes is that apps can no longer use these scans as a backdoor location tracking mechanism when you have turned off the primary radios. The practical effect on your daily experience is close to zero. The practical effect on how much location data you're sharing with companies you have never heard of is significant. Setting 2, accessibility services. This setting requires the most careful explanation because the risk it presents is less obvious than passive location tracking, and the consequences of getting it wrong are more severe. Accessibility services are a legitimate and important Android feature. They exist to help users with visual, motor, or other disabilities use their devices by allowing apps to interact with the screen on behalf of the user. A screen reader that reads content aloud, a voice control app that allows navigation without touch, a switch control system for users who cannot use a touchscreen. These are the legitimate use cases for accessibility services. The technical capability that accessibility services provide is sweeping. An app with accessibility service permission can read everything on your screen. It can observe every app you open, every text you type, every notification you receive. It can see your banking app's screen, your messaging app's conversations, and your email inbox. It can capture this information continuously, in real time, without any visible indication that it is doing so. This is exactly the capability that malicious apps are designed to exploit. The attack pattern is well documented. A malicious app disguises itself as something useful, a performance optimizer, a battery manager, a utility of some kind whose stated function sounds beneficial. During installation, it requests accessibility service permission, framing the request in terms that make it sound necessary for the app's stated purpose. A surprising number of users grant the permission without understanding what they are giving. Once accessibility service permission is granted, the malicious app has read access to everything on your screen. It sits silently, using no visible resources, generating no apparent activity, while it monitors your banking app logins, captures your passwords as you type them, and transmits the captured data to whoever deployed the malicious app. This is not a theoretical attack. Documented cases of banking credential theft via accessibility service abuse have been reported across multiple countries. The malware families that use this technique have been found in apps distributed through the official Google Play Store, not just through third-party sources, though Play Store vetting has improved significantly in recent years. Here's how to audit your accessibility services right now. Go to Settings, tap Accessibility, look for a section called Downloaded Apps or Installed Apps or Services, which shows apps that have been granted accessibility service access. This list is separate from the built-in Android accessibility features. Look at every app in that list. For each one, ask yourself one question. Does this app's stated function require it to read my screen? Legitimate accessibility apps, screen readers, voice control systems, switch control apps, the tools specifically designed for accessibility purposes have obvious answers. Their function is screen interaction. A battery optimizer, a file manager, a phone cleaner, a device accelerator, any app whose function does not inherently require reading, your screen has no legitimate reason to have accessibility service access. If it has it, either it was granted accidentally without understanding the implications, or the app is using the permission for purposes beyond its stated function. For any app where you cannot identify a specific, legitimate reason for accessibility access, revoke the permission immediately. Tap the app in the Accessibility Services list, find the toggle that enables its service, and turn it off. The app will continue to function in its stated capacity. Legitimate apps do not require accessibility service permission to do what they claim to do. If revoking the permission breaks the app's functionality in a way that the app's stated purpose does not explain, that itself tells you something important about what the app was actually doing. After auditing the accessibility services list, establish a personal rule for future permission grants. When any app requests accessibility service permission during or after installation, treat that request as a significant decision point rather than a routine obstacle. Ask what this app does and why it needs to read your screen. If there is no satisfactory answer, deny the permission. Accessibility service permission is one of the highest privilege capabilities available to Android apps. Treat requests for it accordingly. Setting 3. Cloud backup configuration. Cloud backup is presented to users as a security feature, and in important respects, it is. If your phone is lost or damaged, a recent backup allows you to restore your data to a new device. The convenience and data protection value of automatic cloud backup is real. But the default cloud backup configuration on Android creates a risk that most users have never considered. It can become the primary attack surface for account takeover. Here is how the risk works. Android's cloud backup through Google One or manufacturer-specific backup services saves significant amounts of data to the cloud by default. App data, settings, contacts, call logs, SMS messages, and depending on the specific backup configuration, application passwords, and authentication tokens. The backup is associated with your Google account. The backup is as secure as your Google account. If your Google account is compromised, whoever compromised it may have access to everything in your backup, including the data and credentials that the backup contains. This creates a specific attack pattern that security researchers have documented and that differs from the typical scenario users imagine when they think about account security. A user who has enabled two-factor authentication on their primary accounts, uses a password manager, and maintains generally good password hygiene believes, reasonably, that their accounts are well protected. But if their Google account password is reused anywhere, or if it was exposed in a data breach, or if they were successfully phished, the attacker who gains access to the Google account may find that the backup contains everything they need to access other accounts, bypassing the two-factor authentication that was supposed to protect them. The backup can contain app data from authentication apps. It can contain saved passwords. It can contain session tokens that allow direct access to other accounts without requiring the password or the second factor. This is not a reason to disable cloud backup entirely. It is a reason to configure it thoughtfully and to ensure that the Google account it depends on is secured at the highest available level. Here is what to do. Go to Settings, then System, then Backup. Review what is being backed up. For most users, backing up contacts, call logs, and app settings represents the genuinely valuable recovery capability that backup provides. Consider whether backing up app data from every application serves you better than the risk it creates if your backup account is compromised. More critically, go to your Google account security settings and implement the strongest available authentication. Enable Google's Advanced Protection Program if you handle sensitive information. At minimum, ensure that your Google account uses a strong, unique password that is not used anywhere else, and that two-factor authentication is enabled using an authenticator app, rather than SMS-based verification. SMS-based two-factor authentication is better than nothing, but is vulnerable to SIM swapping attacks, where an attacker convinces your mobile carrier to transfer your number to a SIM card they control. Authenticator app-based two-factor authentication is not vulnerable to SIM swapping and is meaningfully more secure. The phone number associated with your Google account should also be reviewed. Phone number recovery options for Google accounts can be used by attackers who gain control of your phone number through SIM swapping. Reducing reliance on phone number recovery in favor of backup codes and authenticator app verification reduces the SIM swapping attack surface. The mindset shift that makes everything else work. These three specific settings are important, but the more significant change this video is trying to accomplish is a shift in how you think about your relationship with your phone's settings and permissions. Most people interact with permission prompts as obstacles. An app asks for permission, and the instinct is to grant it so that the prompt goes away and the app works. The permission prompt is experienced as friction between the user and what they want to do, and friction is resolved by complying. This instinct serves the interests of app developers and platform ecosystems that benefit from broad permission grants. It does not serve your interests. Every permission prompt is an actual decision point. When an app asks for a permission, it is asking for access to a specific capability on your device. The appropriate question is not how do I make this prompt go away, but why does this app need this capability and do the benefits justify the access? For most permissions, honest evaluation reveals that the app's stated function does not require the permission being requested. A shopping app that requests location access always rather than only while using the app. A social media app that requests microphone access when it does not offer voice or video features. A game that requests contact access when it has no social or multiplayer functionality. These requests are made because data has commercial value and permission prompts succeed at a rate that makes asking them profitable. They are made because the default instinct is to grant rather than evaluate. They succeed because the friction of evaluation feels greater than the cost of granting. Reversing this instinct is not technically complex. It requires only the practice of pausing at each permission prompt long enough to ask the question, does this app's function require this permission? If yes, consider granting it while using the app rather than always. If no, deny the permission and observe whether the app's core functionality is affected. Most of the time, denying unnecessary permissions has no effect on the functionality you actually use. Occasionally, you will discover that an app you thought was straightforwardly useful was designed to function as a data collection tool that offers features as the inducement for permission grants. That discovery is valuable. It helps you make better decisions about which apps remain on your device and which represent a poor trade between the functionality they provide and the access they require. The most significant barrier to Android users Protecting themselves from these specific vulnerabilities is not technical complexity, it is awareness. Most people do not know that Wi-Fi scanning continues when Wi-Fi is off. Most people have never looked at their accessibility services list. Most people have not thought about the relationship between their cloud backup configuration and their Google account security. This knowledge is not widely distributed because the parties who benefit from users remaining unaware have more distribution capability than the parties trying to inform them. Every device ships with these settings on. The default configuration generates data flows that serve commercial interests. Changing user behavior away from these defaults requires information reaching users through channels that can compete with the ambient normalcy of devices as they ship. Sharing this information with people in your life who use Android devices is a genuinely meaningful action. Not as a lecture about privacy, but as the kind of information sharing that happens between people who know things that are useful to people they care about. Send it to your parents, who may be running a decade-old Android configuration that has never been reviewed. Share it with friends who complain about their phones feeling slow or their battery draining faster than it should, symptoms that can sometimes indicate excessive background activity from apps exploiting the permissions we have discussed. Pass it to colleagues who travel frequently and connect to hotel and airport networks, the highest risk environments for the beacon tracking that Wi-Fi scanning enables. The awareness gap is the only thing standing between most Android users and 10 minutes of settings changes that would meaningfully improve their privacy. The technical access to make those changes exists on every Android device. The knowledge that those changes are available and worth making is what most users are missing. Now you have it. Use it.